So now we are recording. Yeah, welcome to our course in web engineering in the summer term of 2021. My name is Christoph. I'm a PhD student of Albert here at the Department of Software Engineering in Kassel. And I do the course together with Peter. Peter is PhD in mathematics, so he is a little bit more theoretical on the theoretical side of the university. But he founded about 15 years ago.
15 years.
15 years ago, a software company here in Kassel, the Ticket Toaster, which is a software as a service provider for event ticketing and online e-commerce in general. So maybe, especially our German followers here, have bought a ticket via the platform of Ticket Toaster.
Hopefully.
For example, if you were at the Open Flair or whatever, you used their platform. And yeah, that's the reason why I asked him if he is interested to help me with web. Because I'm more or less a beginner in this topic, and Peter is more a pro user of all the web technologies we like to use in this course. What will we do in this course? We want to build a full stack web application with Ruby on Rails. So, first question I've been asked from a few of you is why Ruby on Rails? There are a few reasons for that. One is, I think it's a good idea to know as many programming languages as you can before you leave the university, so that you have an overview over what's out there. And I think Ruby is nice programming language. And the second reason why you would choose a programming language or framework like Ruby on Rails is your availability of developers for this framework. So I have here one of, I think, at least Kassel's best Ruby on Rails developer. So
there's still Enno. You never forget Enno.
Okay, I forgot about Enno. Okay, maybe he's a second. So yeah, that's the reason why we choose Ruby on Rails, and I think it's a nice framework to learn with, to deal with the web. So. Yeah, we have here some slides. There. Ah. Yeah.
Lovely. Yeah, great.
Here are contact informations. We will put the slides on our blog. Who didn't know where to find our blog? Do you know? Oh, yeah, great. So, more for the introduction, Peter?
Yes, thank you very much for these lovely words. Great to see you here. When we started with Rails with version, I don't know, something like 0.8 or something, really one of the very first versions, and this system has emerged a lot and has evolved a lot through the years. We are at version 6 now, and the first version of the ticket shop or the e-commerce system we actually built started in 2005, the first Ruby version. But we've restarted a couple of times because things really changed a lot. And I think I have a pretty good overview of what Rails actually is. And one thing that's really, interesting from a student's point of view, I guess, is that in Ruby you have a lot of very uncommon concepts. So there are a lot of things that are pretty different from other languages. There are things that look pretty much like Lisp. There are other things that look like Smalltalk. And there are quite a lot of things that are pretty interesting. And so I guess it just broadens your view of programming languages. And even if you decide that Ruby is not what you love, it might change the way you think about implementing, especially APIs or framework code. So I guess it might change your mind or broaden your mind. So today and probably next week, I guess, we will be talking about Ruby itself. So Ruby on Rails is the framework, and Ruby is the language the framework is written in. And although when you start Googling for Ruby on Rails, you find a lot of tutorials where we are pretty much ignored and pretty much just used as an DSL for writing web applications. But I think this is not the way students should look at it. But we should really try to understand what's really going on behind the scenes and really learn things. This is what it's all about. And so we decided to say some words about Ruby today. we're not trying to make a complete introduction to every aspect of the language or to explain in detail how things are to be written. I guess you are all able to use Google at least as good as we are. Another visitor. So we'll be trying to introduce the language itself a little bit today so that you can start searching your own path. The language is, every detail about the Ruby language, about the history and about the way it's made and all the stuff, you will find at rubylang.org. So this is just, I had to introduce this little rant about JavaScript because everybody is telling how great JavaScript is, and it's really just a mess. We tried JavaScript, we tried PHP, we tried Java, we had everything, I guess. And in the end, we found out that we were we are fastest when using Ruby instead of all the other languages. Yeah, just some words about the history of this language. It's created in 1995 by a very nice Japanese guy. You might find a lot of grammatical errors in the API, like a string start with another, not starts with. This is all these come from Matt's limited English skills, but he's a really cool guy and he made this language and he's still lead developer there. And it took parts from Perl, Smalltalk, Eiffel, Ada, and Lisp, and probably a lot of other languages. The Perl heritage is mainly the fact that you can use it to do real command line scripting. So this works very well in Ruby too. Smalltalk is probably the most object-oriented language you can think of, apart from Ruby, of course. Especially from Lisp, there come the functional aspects of the language. It is written in C. There is a Java version too. So if you at some point have the impression that you prefer the Java deployment system, you can use your Ruby scripts and run them in JBoss or whatever. It's an interpreted language, so there's no compiling. It is extremely object-oriented. It is strongly typed, that is, everything has a proper type. So this is very much in contrast to what happens in PHP or JavaScript, where typing is, a little bit flaky. In Ruby, everything has a proper type, but it's dynamically typed. So you don't declare the type of a variable before using it, and you may assign different types to the same variable. The philosophy behind this is duck typing. This is what it's called. Should have written that here. Duck typing means if something looks like a duck and behaves like a duck, it might be a duck. So you can you don't have things like interfaces or so, but you really just use the objects and to some extent hope for the best. But this works pretty well. You'll see. It's functionally inspired. So this is the Lisp heritage. Just some very, very basic words. Ruby files are supposed to end with RB. There is a command line Ruby interpreter that just takes a file name and then executes the contents of that file. You can use shebangs and make the files executable so that you can use them as shell scripts for the Linux friends. This is supposed to go on. There's IRB, which is an interactive Ruby. So you have a REPL where you can just type in your commands and you will see the results. And with most operating systems, well, probably not Windows, but every Linux and Mac, there comes an installed Ruby version, but this is generally pretty outdated and pretty inconvenient to handle. So to actually install Ruby, I suggest using RVM. This is the Ruby version manager. RVM.io is the URL. You should really get it there and install it from there. Because any other way of installing it is pretty cumbersome. There is an alternative, but I suggest we all use the same, so we run to the same problems. It's probably easier to help then. After installing RVM, you say RVM install and install the latest Ruby version, which is 3. You then tell your shell to use this version 3. And I really suggest not to use the system installed Ruby because installing extensions generally requires root writes, and this is pretty cumbersome. But the version you install with RVM is easier to maintain. As I already said, rubylang.org, you will find a lot of more details. For Windows users, there is a Ruby installer thingy. I never used that, but I think it is there. So you should have a look for this or at this. But you could also use the Linux subsystem, the Ubuntu stuff, and install it there. That should be working as well. Some quick words about conventions. For variables in general and method names, lower snake case is used. And these are used for file names too. Upper camel case is used for classes and modules. We'll go into modules later. Screaming snake case is used for constants. Instance variables are prefixed with an @ Class variables are prefixed with 2@, and global variables are prefixed with a $sign. But in general, in most cases, using global variables is not right. Just try to avoid it. There are a couple of system global variables, like the last error or the command line arguments and stuff. They are prefixed with a $2. That's not that important, I guess. So you have some, of course, basic data types in Ruby as always. Integers and floats are, pretty boring, apart from the fact that they are always multi-precision. So you never run into an overflow, but you can always just add on and have really, really big numbers. And this is pretty fast and pretty convenient to just have it at hand, especially when you're doing things like cryptography or handling with very complex encryption or conversion things. This multi-precision stuff is really, really neat. There is this very special data type which is symbol. It's written with a colon and then something. This is pretty much like a string. The only difference to a string is that these things are singletons. So, you could just... I originally wanted to show you what we did, but he introduced everything, so I hadn't to. So I'll just start the interactive Ruby. No. All right. Yeah. So is this big enough? Can you read what I typed there? Yeah. Okay. Okay. So I'll try to make it a little bit bigger. All right. Better like that? Albert, your microphone is off. You're muted. Okay. All right. So, of course, whenever you have some problems, just interrupt me. Yeah, just let me know if there's something you're not happy with. As I said, numbers are very much like you expect them to be, and you could also do things like this, which is the multi-precision stuff, which is quite handy. Floats are written like floats are written. Strings there are two flavors. The one with a double, not backtick, what are they called? The double thingies. Quote, thank you. Yes. Yeah. And the single quoted, the only difference there is string interpolation and the handling of certain special characters.
Escaping does not work with
single quotes. The single quotes don't do escaping inside, whereas the double quotes do. So I'll just make something very, very simple. Just make a local variable a, and with double quotes you can say this. And will be interpolated, and if you do this with single quotes, this just doesn't work. This is the main difference here. But that's not that interesting. The symbols, I know you hate it, but I do it still. Symbols are written as colon something, and they really just stand for themselves. The symbol has no semantics, but it really stands for itself. And whereas you can, if you have some string, everything has an object ID, which is a very internal thing. You don't normally look at it. But if you look at the object ID of this string, it changes because every time I type it, it is a different string. It looks the same, but it is a different thing there. Bigger even. Okay. But with symbols, this is not the case. The symbol stands for itself, and it has the same object ID every time it's accessed. So symbols are used in Ruby quite a lot to in an enum kind of way, and to transport more static information than a string does. So you have, for example, you may use it to represent the status of something. It's often used for things like that, and for names that really don't change. Oops. Yeah, we have tons of syntactic sugar. Arrays are just written the way you expect them to. The hash thing, yeah, I'll go into this. Yeah. So there is a syntax to write hashes directly. So you can have a hash where one maps to A and 2 maps to C. To be at least a little bit surprising. You assign this to the local variable HS, and you can then access the keys. And if you ask a hash for something that's not inside, you can it will always return nil. But the keys can be arbitrary objects, and really arbitrary objects. So you could have things. You could define, for example, the class string maps to who. And then you can access this too. And this may work with, you may, on the left hand side, you may have any Ruby object that you can think of. So pretty much everything you can think of. On both sides of the hash, and there's no type checking. So every hash can have keys and values in very much the way it wants to. So you could also have things like 22, or oh, this is something broken. I guess I have to restart because the line width changed. So you can have strings, name, can have string keys, and you can of course have these symbol keys. And for the symbol keys, there's a way to write them a little bit neater. This is, well, I don't know what's going on there. There's something broken in the terminal. You can write them in the JavaScript notation. That is the key colon and the value, and it will then be a symbol key in the hash. And of course, you can access them like that. But of course, obviously, as a string is not a symbol, this does not work. So it's really just a different object. For arrays, I just probably clean the screen because this. Oh, maybe we'll see. For arrays, this is poor man's prime numbers. You can put in an array. You can have whatever elements you like again. So there's no type checking. You don't have an array of, but you have just array. Put in what you like. They are zero based. So a of 0 is 1. Whatever. When you're using negative indices, it starts counting from the back, which is pretty convenient. You can have ranges. That is, if you want the elements from 2 to 4, you can just enter it there. This 2 ... thing is it's a proper object. So 2 ... 4. This is not syntax, but this is really an object. So we could. This is a range object. And they are used for different purposes. You can look whether numbers are within a range or ranges overlap or whatever. And they are used for accessing indices of arrays too, which is quite convenient. You can do things like, so I call this thing A. So if you say x is A, then x is A, obviously. But if you say xy equals A, then x is the first, y is the second. If you say x star y is A, then you have x is 1, y is the rest. So this is the remaining elements. And if you do things like that, then you have x is 1, y is the middle elements, and z is the last element. This is, in this way, for example, functions that are returning multiple objects can be implemented pretty easily. So if we have on our list, so we can ask this list for its minimum or for its maximum. And there is another neat function which is min-max. All right, no underscore. And if you need these into variables, whatever, then you can say PQ equals L of min max, and P will be min and Q can be max. So you can easily implement functions returning multiple values and assign them in one go, which is quite nice often. All right, I guess that's and from the command line heritage, the Perl heritage of Ruby brings some other interesting things, like you can have blah blah. It's just a shortcut to define an array of strings. There are tons of stuff like that really come from the old times when people were using it for command line scripting mainly. I don't generally consider this a clever idea, especially except from very special cases. But there are things like that. We don't go into that any further, I guess. Regexp. So we have say pattern equals \d plus x, for example. And if we now have a string, some numbers x, we can say p dot match this string. Should have assigned it. P dot match this string. You'll have some match data. Assign this again, and so this is the actual match. So within the string, it finds this to be matching to the given regexp pattern. The regexps are pretty much the same as they are in every other language. Just some minor differences, but pretty much normal. What's a little bit surprising, I guess, from people not that have never used Ruby before, is you can write things like this. So you can say the string and give me the contents of the pattern. You could, can extract things. You can extract strings, substrings that match to a certain pattern pretty easily. So this is what should not have happened. I wanted to disable them, but I don't know how. Schalten kurz in Kamera. Bitte. I just quickly disable the notifications, sorry.
Where was the D&D button?
Das ist echt eigenartig. Anyway, okay, danke. All right. So regular expressions are first-class citizens of the Ruby world. I guess that should be enough for just these basic data type stuff. Right now, there are other things that, but most of them are pretty much the same as in other languages. Classes. As I said, Ruby is strongly typed, and everything is an object. So really, as in everything. Just clean the screen a little bit. So if you have a number, 1, 2, 3, whatever, and we can then ask, what's the class of A? It is an integer. Say 1, so B is a float, and anything you can think of has its has a class. So I used. I guess I already showed you this. This is a range, array, whatever. So array itself has a class because it's a class, and the class of class is class. So the Ruby language itself is very much made up from itself. So there are pretty little language elements, but very many things are really made inside the language. And you can, this is really just for shits and giggles, but you can instantiate a new class. And you could then take this and make a new instance of this newly instantiated class. That really doesn't make a lot of sense in this situation now, but it gives you the opportunity to act in incredibly dynamic ways and to, at runtime, construct your own classes and give them all the functionality you need and handle them around. And this is, it's rarely used in user-facing code or code that's facing a normal programmer. But when you're developing libraries and framework stuff, these are things that you're using every now and then at least. Everything has a class, everything is an object. There is a concept. So really just very stupid. You say just define a class which does nothing, and then say a.new. This is then obviously an instance of A. Doesn't make any sense so far, but this is really just the way classes are made. And there are modules, and these modules are used to, in Ruby you have a straight line of inheritance, so you don't have multiple inheritance. But you have these modules, and you can define a module which is something like an interface for the Java guys. But it has its implementation, and you can, when you mix in a module, it's called include, then the functionality implemented in the module will be inserted to the class, which is a pretty good alternative to having multiple inheritance, because it's pretty clean, and you always have a clear chain of superclasses. So you have this chain of superclasses, and whenever you include something, there is a module put in between, but you're still just climbing up the ladder, and you don't have the situation that you don't know from which side to take the function or whatever. But everything's pretty clear there. Right. What's special? So there's a lot of things that are pretty uncommon for people, especially from the Java world. Or C, even worse. Classes in Ruby are open. That is, you don't. The language itself it's in. Having a question or someone? No. So the language is interpreted. So you can at any point during the runtime of a script define another class. But you can also, at any point during the runtime, add things to classes. So, just clean this. We say as is a string, we call it, we're in England here, in English here. So, hello. Obviously, strings don't have a what function. By the way, functions may end with question mark or bang. But we don't have undefined method what for string, which isn't too surprising. But we can say class string, which is a class that's already defined. Define what? And return self-bang. So when I call s.what, it is hello bang. This may look pretty embarrassing for people that are used to static code. But it gives you the chance, for example, when we are using the Rails framework later on, we will see that they added a lot of convenience functions to string. So, the framework itself brings things like upcase or downcase, but when you're using Rails, string is enhanced by a lot of functions. They mixed in another module, and these the functions that are inserted are things like capitalize or underscore or camelize or whatever. You can do a lot of bad things with this, but as long as you're doing, as long as you know what you're doing, this is a great way to produce very readable code in the actual program. You can really move the nasty stuff into the framework, and of course you can always inherit from string and do things with and then have a new string. I have a my string and this has more functions, but these my strings you then have to explicitly instantiate in Java, for example. Many functions don't return a my string, but they return a string. And so when you have the possibility to just pimp the standard string class, you get a lot of flexibility there. This is the open classes stuff. Yeah, very dynamic. Already said so. Today we're intentionally doing a lot of shits and giggles. So this is not supposed to make you really familiar with the language. I just want to give you the impression what can be done here that probably can't be done in other languages. So we have this string here, and we now instance. We now define an instance method. We want to call it yes. And it's supposed to take no arguments and return this and the string itself. Define. So what did I do wrong there? Define instance method. For hello string. This should be working. No, this is not the nasty stuff. No, it's not instance. It's define singleton method. Yeah, so it's even written there. I'm so stupid. Sorry. There is a define instance method too, but it's used in a different place. Define singleton method. Sorry, my apologies. So when I have some string and I call yes on it, it won't work. But I have my string, which got this function defined, and I call yes on it, it will work. So I can even have objects of the same class that may have different methods available. Sounds like a pretty bad idea, but there are situations where you can use this to just enrich objects to mark them in some way. For example, if you this is a node of something that I already had a look at, or something like that. So it's not used a lot, but it's just convenient to have it around. And there is a thing like method missing. So you can say I want to intercept any method call that I don't normally respond to, and I want to get it as a string, and I can have a look at it and decide what to do with it. Which is how in the early days the database access was implemented. So when you got a row from the database, and you then used .name, it then had a look: is there a column called name, and will return the value there. It's not done like this anymore, but it was in the old days. And again, this can be very convenient, yeah. We will probably see some situations where it's even reasonable. Yeah, there are many structures or constructs that you normally supposed to be really language, but they aren't. They are really just library code. I guess private is written in C, but it's really just a friggin' function. And you already saw some do-end blocks, do-end and yield. The do blocks in Ruby, I will probably just use the oh, this is too big.
Yeah, that's all good.
Yeah, but I guess the line is this sufficient? Can you read that already? Yeah. Do it, yeah. So defining a function is done using def. This is all pretty sloppy. We're just really defining some top-level stuff because it's not important. We don't do this when we're doing actual programming, of course. We'll define some function. We'll call it Rapify. And this function, so well, let's first do some normal stuff just to give you an idea. So if we have a function square of x, this will just x times x, x times x. So we can use square of h should be 64. Yeah. Lovely. Every function returns the last thing it evaluated. So in this case, x times x is the last line. So if you have an if, the last line that was actually executed, this is the return value of the function. You can use return, but you don't have to. And generally, you use return mostly just to return at an earlier point in the function. But if you really just have functions that run through, just the last line is what you're returning. So this is a normal function with a parameter. We could even say something like this. So if you then don't give a parameter square without parameter, then x will be 1 by default. And you can, of course, y and whatever, more parameters. This is the normal way functions are defined. In this case, we're not within a proper object, but we're on just top level, which is, of course, an object, but yeah. So, and we'll now define a function Rapify, which takes a block. Yeah. And it yield, and then we will return all right. So now we have this function Rapify, which gets this special parameter type block. So so if you just say Rapify 4, you'd expect to return angles 4. That doesn't work because we gave one parameter and we're not supposed to give parameters. But if you say Rapify do, you can then have arbitrary Ruby code here within this do end block and do some fancy computations and return 4, for example. And you will then get this 4. So yield means execute this block and return the value. In this case, we had a block without parameters. You could also have something like this. So we will take some value and give it into the block. This is then inserted with this. The parameter is inside the pipe symbols. So we can do things like this, x plus 1. So I guess we should get angles 10. Oops. Ah, yeah, I forgot to copy this here. So what we're doing here is we have this. We're calling this function repify with a block. This do end thing is a block. We're calling the block. This is what yield does with the parameter 9. So the 9 goes into the x. We're then evaluating the block, which is 9 plus 1, which is 10. We're getting the result back to the s. And we're then returning the string angle s. So you probably think, what's all this nonsense for? We take an array and say each do and puts the value. So the all these iterators, where you have in most other programming languages, you have constructs like for each, or you have for with some index or something like this. This is all implemented as a proper function. It's really just a function of array. In fact, it's a function from enumerable, but yeah. So you don't have a language construct or language element to do the iteration, but it's really just a function. So this was each. I could also, oh no, let's stick to this. So each just in general returns the array itself. So the return value is the array itself. So here, but in every execution loop, we will output the number incremented by 2. But there's also map, which returns the value of the block executed with each parameter for itself. So this is the way we're all doing all these almost all looping in Ruby is done this way. So I very rarely use things like while or what's the other, repeat or whatever stuff. There are constructs like this too, but in general, you mostly find you have you already have some kind of collection, some kind of array, some kind of hash, for example, and you just map or each through this. And if you're using a hash, so we're using this. Yeah, so this is our hash again. You can say do, and as I showed you with the deconstruction things before, so you can have double assignments. You can here key comma value. Yeah. And all right, what we're doing, we're mapping here. So yeah, again. So what we then get, we are taking we are looping, or we're mapping on a hash which is a set of key value pairs, ordered by the way. So hashes do keep their order, and we map, and in every loop we are deconstructing key value, and so yeah, this is the way looping is done in Ruby normally. There is for each or something like this. I really never used it because it's just not, doesn't give you any advantage. It's really just this is really the way things are done normally. Yeah, right. By the way, if you have the impression you don't know how to implement a map function with yield, this is not a problem. So you don't use this a lot in your application code. This is things that are used in library or framework code mostly. Exception handling, yeah, you're just raising. So raise and give a string will produce a standard error, I guess. Yeah. Again, this can be done on interactive mode. Okay, runtime error. All right. But you could also raise a something error. So you can have subclasses of runtime error, and you can give them special functionality, special parameters, whatever, same as or similar as in Java. And there is another pretty neat thing that it's rarely used, but it's a great way to handle some edge cases. There is this anti-pattern of using exceptions to deep return from deeply nested code, and this is you're not supposed to do this in Java or on any language. But in Ruby there is this throw catch thing, and you can this is while raise and this begin rescue stuff is really supposed to be error handling. Throw catch is supposed to be control flow management. So you can throw an object in a deeply nested structure and will then return up to the first point where it finds a catch block that will catch the thrown thing. So generally in the example, we will throw ball, and somewhere up in the call stack there is a catch ball, and you will return there, and we'll have then a special return type, and we'll be able to handle the situation. So it's a way to do deep returns. We use it very rarely, but it's convenient to have it around. All right. So what time is it, by the way?
3.
Okay. Ich würde gerne mal was trinken. Ist das okay? Kurz Pause.
Ja, kannst du einfach trinken.
Ja, ich werde einfach was gut tun.
So. Willst du richtig Pause machen?
Ja, sind 5 Minuten. Ist es okay oder ist es irgendwie doof?
Ja.
Okay. I'd love to make a little break before we go into the next part where we're actually implementing something more reasonable than all this playing we did until now. So I suggest we'll do a break like 5 minutes or so, if it's okay for you. So we'll back at 3:05. Yeah, lovely. So see you then.
There was a question about 30 minutes ago. If we only use Ruby in Linux or Mac. We do it only use on Linux or Mac, but you can use it on Windows if you want. So there is the Ubuntu Windows something shell. I don't know how it's really named. Albert, do you know? Yeah. That should work fine. So you can use it on Windows too.
By the way, we have strong types. We just don't have static types. Yeah. Yeah. All right. Yeah. I should have gone from bottom up.
Yeah.
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 Just be overridden. Yeah, generally, the situation when you're really, so this is called monkey patching. So when you're changing functions that are already there on objects, this is generally considered bad style, and it's really just it's really done only in very special situations, and especially generally you will have people will be very careful about this. But you can really destroy everything. So if you're changing, you're switching upcase and downcase for strings, something like that, everything will break. Of course, yeah, this is true. Yes. If you, I have to repeat the question, don't I? Yeah. So when you have two libraries that are both changing or adding a new function to string or whatever, and they are doing it differently, this will break things. This is definitely true. But these are things that aren't just done under the hood, but generally, in Java or PHP or whatever, you have a lot of things that are just made sure by the compiler. There's a lot of safety that is integrated into the compiler. Where in the Ruby world, the programmer has a lot more responsibility. So you can really do nasty stuff. You can really break things. But on the other hand, you have the opportunity, or you have the chance to really change the behavior of
the language
of the language and of the objects you're handling, and you will find that the community is pretty different. So the way people think, the way people craft their libraries it's really different. So introspection is something that in Java, I guess a lot of people never really looked into that. They heard about introspection. There is such a thing, but they never did it. And in Java, in Ruby, introspection is it's just normal. And you can, for example, define some block within the context of some object, and you can take this block, handle it as a parameter, and evaluate it in the context of a different block, in the context of a different class. This sounds pretty strange from the Java point of view. And I know that, for example, the Scala guys, I had a time when I was using Ruby and Scala in parallel, and the Scala guys really hated that. They said, oh, this is all just broken by design. And I tend not to agree. With great, this is the Spider-Man thing. With great power comes great responsibility. You have to know what you're doing, but it gives you the chance to develop DSLs and to make code that is incredibly concise. So the library code may be ugly, or may contain things that look nasty, but it gives you the chance to write application code that is incredibly clean and incredibly short. And this is why we still stick to Ruby. So we really tried a lot of other things, really a lot. And in the end, we returned because we had the impression that this language is so expressive. So if you're trying to well, today is the advertisement day, so I will just talk about things. One concept that is pretty much used in Ruby is metaprogramming. So you're actually writing code that is writing code, but not in a sense of we're producing a file that is later then compiled, but it's really you're writing code that is producing code at runtime. You're producing dynamic classes, you're producing dynamic modules, and you're including them dynamically at some other point, and you're evaluating stuff places. And this is well, it's kind of brain fuck, I agree, but it gives you the chance to make things very, very clear and very, very, very simple in the final interface. And so, yeah, with great power comes great responsibility. That's the main point. There are a lot of things you have to take care. You have to be careful. But when you are careful, and when you're making sure you don't do stupid stuff, you'll get a language or you're getting code that is very, very concise. I guess when we are later on, we've used stuff the standard way. I will probably show you some of the abbreviations we built for ourselves, so that you really just write the code that you strictly need. There isn't, well, apart from shortening the function names, there's really no way to make things any shorter. It's really just the stuff that you need. And so this is what I really love about this language. And it's just, you can just read it. It's not text, of course, but it's not literature. But especially when the DSLs are well crafted, you really have the impression, well, this is the way it should be written. And whenever I have to go to other languages for whatever reasons, I feel pretty annoyed. So that, of course, Ruby has its rough edges. So there are points where you think, well, why that? For example, the typos in the standard library. Why? But C has them. So create without an E. What's that? Well, I always get into talking. IDE, what's that? No, I personally am more the editor kind of guy. But I think RubyMine, you tried that, didn't you?
I use RubyMine. I think, where is Leo?
Upper right.
There's Leo. Leo, I think, use Visual Studio Code.
Oh yeah.
You use Sublime Text. Use whatever you want.
VI is considered one of the best editors, I guess.
Yeah. It's, in the end, it doesn't matter. I like Ruby. Yeah.
Oh.
Yeah.
Bloatware.
It's not. There are some convenience you get from an IDE like RubyMine. RubyMine is, I think it's free for students, but if you're using it professionally, it's quite expensive. So yeah. But the convenience you get is not that great. It's not that much. You get the breakpoints. That's one point I like. You can just add a breakpoint somewhere and break your control flow. Especially for that's especially convenient for background workers. Not for the main control flow you have in your. Yeah, it's a bit complicated if you don't know Rails. What is the background worker? So
it's a non-front end, non-web.
Yeah, it's a
worker.
Part of your.
It's a background worker.
Yeah,
in fact.
it's a background worker. Some kind of code that runs in the background now and then. Whatever your schedule, what your scheduler says.
Yeah.
Yeah.
So there's this in Visual Basic I can write then, and this is true for Ruby, by the way. So the if stuff is in fact if condition code, else if another condition, more code.
That's what.
Oh yeah. Thank you. Thank you very much. More code, else, root. So this is the standard where you're writing if conditions in Ruby. One thing that you could or should or may have in mind is these do blocks actually produce a scope barrier. So the do block has its own scope, whereas an if condition doesn't produce a scope. It's really just control flow. And if you have a short thing, or if you want to stay in the same line, you can do it like this. So you can have one line ifs. One thing that's pretty unusual for most people, I guess. So we say def greet of name, and we return hello. Oops, where is it? Name. No. So this isn't too surprising. If we're saying greet name, you'll say greet Christoph, you'll get hello Christoph. But if name equals Christoph, let's say puts. So we can say we will greet everybody, but in Christoph's case we will greet a little bit more happily. Or oops, this is not what I expected to happen. So and if we say I do not expect you to be impressed, but this is from a. It doesn't really. The code doesn't really look nice. I think, at least I think so. And in Ruby you can put it like that. So in Ruby there is a postfix if, which does exactly the same thing. I get the syntax tree for this. For the code is even the same. And if we're happy with everybody except of Christoph, we can say if name unequals is unequal to Christoph, of course, or we could just say beware unless. So in Ruby there is a negated if. It's really just the same as if, but the other way around. And especially when you're writing it in this postfix way. So when you're writing it in this postfix way, unless can increase the readability of your code quite a lot. It takes some time to getting used to it. It's not, it's quite unusual in the beginning, but at some point, well, at least I love it. And what's a situation where I love it most is when you're using it like this. So if you're saying return unless name length, something like this. This is really just it's so easy to read. So it's really just when you're having a look at this code, you don't when you're quickly reading over it. You see return unless something. All right, I don't have to look at the actual condition. Whereas when you have this if something then return, you have to first pass the conditions, and especially when the conditions aren't so important to some extent. This is just convenient or a nice way to write things. Again, you don't have to do that, but it's a possibility to, well, increase readability from my point of view, especially in cases when it's reasonable. What you should never, ever do is use unless in conjunction with and or. This is really just your mind will blow, I promise. So unless name length bigger than 1 and something, you just get confused, I guess. It has a very proper meaning. It's really just if not. So yeah, nothing specific, but generally people will not understand what you're doing there. And I guess in most cases you yourself will not know what you're doing there. All right. And so, by the way, this is and, this is or. And or can be used. So when I have something, when I'm joining something with an and, so say A and the result of the evaluation will be the last element. So you can replace quite a lot of if stuff by using and or in a clever way. So you can just have chains of objects, and you're really just getting the first or the last object that's defined or not or whatever. And everything, in Ruby, nil and false are falsy, and everything else is true. So empty string is true, 0 is true, everything is true except false and nil. And by the way, I forgot that before.
Yeah.
It is too sad. Nil is a friggin' object. So you can call functions on nil. So of course nil has a specific semantics. So it represents the nothing thing, and it of course it is false, but you still can do things with nil. Of course, true and false are proper objects. This is nothing. There's nothing special about nil or false or true or whatever. Yeah, I've never tried that. No, you can't change the way you can't change. No, in fact, these object IDs are pretty. You never use them. It's really just to explain things. True has the object ID 20. I forgot that even. False has 8, I guess. No, 0. Oh, so nil is 8, isn't it?
Nil is 8, yeah.
And these are singleton objects. Nil is a singleton object. You can't have another instance of nil class. You can't have another instance of true class. And deep inside the C code of Ruby, where it's decided whether or not something is truish or falsish, really just the friggin' object ID is compared to 8 and 0. So really these two are the only things that can ever be false. This is performance reasons, because otherwise if you had the chance to implement a am I really true function in some way, then evaluation would become so much slower, because every object you'd have to take it into your hand. You have to look whether does it respond to this function and call this function and look what comes back. This would be so cumbersome that being truish or falsish is something that is really just a matter of being the false object or the nil object, and really they can't really be overridden. You can add functions. You can say nil define singleton method. I think. Well, I tried. I guess I can do. Let's define a singleton method. Oops. Oh, probably oops. Nil. This might seem completely crazy, but again, it gives you the possibility to add. So when you're dealing with Rails, as I told this, for example, the string class is enhanced quite a lot. There are a lot of functions that string normally doesn't have. And one thing they added is the function present. And near present. So I can't show this interactively because we're not in action. Action active support. They add a function .present to everything. And nil obviously isn't present. This is just reasonable. Some proper string is present. The empty string is not present. An array with some elements is present. An empty element is not present. This is something that was added by this require active support here. This is one of the libraries that comes bundled with Rails, and I added it. I required it just here, not using all of Rails, but this small library, and this enhances strings and arrays and whatever's to be able to use it on to ask them whether they are present. I don't know what happens with true and false. This is just the way you expect it to happen. And this gives you the chance to write things like or in Java script Java, I don't know. You recently find things like if string and string length do things. This is proper. You find this very frequently. So if there is something is actually there, and in Ruby you can, when you're using active support, you can say if str.present, and it's even a little bit worse or better. Of course, better. Who am I? So the empty string is not present, even if it contains white spaces. So only a string that contains non-white space characters is present. This is just, it's a convention. You don't have to use it, of course. And if you really want to know whether it has a length more than one, you can ask that question. Or if it's longer than 0 elements. This is especially in web applications where you have to deal with input, the result of input fields, and you may either people entered something and deleted it, and it is an empty string, or the contents may be filtered for some reason or never be transferred. And being nil, you find you'd have to deal with stuff like this quite a lot. And in Ruby, well, you don't have to, because you can just put it like this. There's even something. I'll do that. There's presence, which is just a little bit more crazy. It turns everything that is not present into nil, and everything that's present into itself. Again, this is incredibly convenient. It has a very special semantics. And if you don't like this semantics, you just don't use it at this point. But there are a lot of situations where you just don't care whether what something that is not present actually is. You just want to ignore it. So somebody had a question. I can't understand you, I'm afraid. You want to type it probably? Oh, yeah. Yes. Okay. He's typing in the chat.
I think there is no question.
Yeah, probably. The question will show up later, so we'll just go on for the moment. This is. Sorry, I'm afraid I really can't understand you. Please type. All right. Oh yeah. So I promised you to. Well, yeah, I'm playing all the time. So for today and for the rest of today, we wanted to do some real worldish stuff, just to actually use the language for doing something more reasonable than looking whether an empty array is present. And we thought about just having a small thing to manage your rooms. So we have the rooms like these here, and we want to write some great library to manage them. So the first thing we actually need to do that is some room class. From the Java, or I think from most languages, you'd expect to first define the available instance variables. We don't have to do this in Ruby, so we're just using an instance variable, and then it is there. And if it isn't defined at that point, it will be nil. That's it. Different from languages that have constructor, in Ruby we have the alloc init pattern that's used in Objective-C, for example. So when calling new, an object is allocated, and then initialize is called for it. So initialize is the constructor in a Ruby object. The difference doesn't really matter. So we say we have a room, and we initialize it with one thing, and we say name. This is the instance variable, is the parameter name. So, I'll stick to copy pasting for a moment. Okay. Just like that. So now we get a room equals to room.new. We will then get an error because we forgot to give the parameter. All right, so now we have a room object with a name 1337. There's not a lot of things we can do with this object apart from looking at it. So if we want to ask, what we can't do is ask the room for its name, because there's actually no name function there. So if we want to have to access the name, we define a name function, which just returns the name instance variable. Ich weiß es nicht. We'll just require the file, and again say room equals to room.new 1337, and we can now ask the room for its name. What we can't do is change the name. We can't say room.name equals 1338, because there is no setter defined. In the Ruby world, we actually define setters as something as a function that ends where the function name ends with an equal sign. Name equals to X. I don't think this is a good choice.
You may explain what this require things.
This is, yeah, as you may have guessed, require is just a way to load code from a file. So I saved the stuff right on the right and just load it into the interpreter. And again we say room equals to room.new, and we say this is the name. So another name this time. And then we can, this is the way an object is represented when there's no better way to do it. It's really just the object ID, the class, the object ID, and the list of the instance variables. And as you see, we said room.name equals something, and we now have this this name for the room. All right, so this is probably strange in the first place, because you normally don't have in other languages you don't have functions with an equal sign. You can even do things like override functions like the brackets operator or the brackets equals operator and whatever. Overriding functions, very much you just write them very much as you expect them to look. But this is boilerplate code that is very, very stupid. You don't want to have boilerplate code like this in your applications. So for this, there's an abbreviation. Azure accessor name. This says I want to have an attribute accessor for name, which is the getter and the setter for name. So the object is now very much the same as it was before, but now with the code for the setting and getting of the name variable are hidden into the accessor thing. Still works, and obviously still works. One thing I didn't say so far. So instantiating is not a language construct. So this new thing is not something that's has some special language feature, but it's really just a function of the object. So the base class of everything is object, and object has this new function which is responsible for doing the allocation and then the instantiation with the initialize, data initialization with the initialize method. So there is no new room, which is where the new is really something that the keyword in the language, but here new is not a keyword. It's really just a method of the object or of the class room, the class object. Something you need to get used to, I guess. So, but we want these rooms to have more. We want it to have a floor, and we want to have a building. And these, of course, we want to have accessors for. But the building is main unless differently specified. All right. So now rooms have name, floor, and building. We don't declare them really. We don't really declare these instance variables, and we during the course of an application, there may be different instance variables that show up and that are used or that are not used. This can happen. Oh, there's a question. All right. So there's a question about scoping. Yeah, we can go into this. Yeah, anyway. When I define the local variable, this is then a local variable of the actual of the current context. So we're currently in some main object which is used to be the wrapper for every online or for any evaluation on the command line. Then this is a local variable, not an instance variable, but a local variable of the current scope. If I say 3 times do, so times is a function of integer, by the way, and I used I puts I and in this case I is a in this block, in this do end block, I is a local variable of this block, and it's caught in the scope. So the outer I isn't changed. But the outer I is available inside the block, because this is really just really just the way the binding works. So this is then which kind of scoping is this?
Is there a name for it?
Yes, of course. Well, yeah, the kind of scoping we expect it to be. So the I is available there. But things are worse. I told you everything is an object. This is the object which represents all the current local variables. So the current. So you could even access your own evaluation scope and change it. This is done very, very rarely, and it's generally not a good idea. So when you're trying to modify the binding object, you're normally doing something very wrong, and you should restrain from it. But it is possible, and there are certain situations where it may be reasonable. But yeah, this is something you don't generally want. All right, so back to our room management. So now we produce our room 1, which is room.new has some number, wrong number of arguments, expected 2 or 3, which is, well, at least these 2. This is optional. So floor 1. And room 1.building should be main then. Yeah. Yeah. So now we have our room, and well, yeah. One thing you might find it's always a little inconvenient. So if you room.new with 2 parameters, what do they actually mean? You don't really know that. So it's so what is which parameter means what? It's a little inconvenient. So we can switch to using named parameters. And this is something that was introduced rather recently. So, I don't know, 3 years ago or something. Room new map doesn't work, and required keywords name and floor. So the name of the room is this, the floor is that, and the building is this. Yeah, apart from typos. And of course, the order of the arguments doesn't matter. You can write them in any order you like, of course. Otherwise, it wouldn't be so very helpful. And you can omit the building parameter because, as you see here, building has a default value, whereas name and floor don't have. So R1 dot building is main. All right. Okay. So next thing, we want this room to give a reasonable representation of itself. So we define a full name function, which is name, floor, building. Yeah, pretty stupid. So yeah, just does the obvious thing. And in fact, we want to know whether there can be a lecture in this room, because not all rooms are equal. So we say there is a classroom. It's always funny with these things is you're running into classes and modules on different levels of the. It always happens.
Just use lecture room.
Okay. And this inherits from room. So a lecture room is really just a room now, and we want it. Oops. To have a capacity. And this needs to be set. For a lecture room, you have to say what's the capacity, otherwise it doesn't work. The concept of super in Ruby is very different from the concept of super in most other programming languages. So super is not the super object, but it's if I just said super, it would really just call initialize on room with exactly the same parameters. But in this case, we want only the parameters name, floor, and building, because the normal room doesn't have capacity. Name, floor, building. Oops, again. So this is really little place. And after this, the local variables are set by the super constructor or initializer, and the capacity is the capacity given here. So, and we can now, instantiate lecture rooms. And we want to be able to ask a room whether it can be used for a lecture. They have is this room lecturable? And we could now either say it by default it isn't, or we could raise an exception here. But let's just say by default it isn't. And we define lecturable here, and we return capacity bigger than 0. Because otherwise, if you have a lecture room with a 0 capacity, you can't have a lecture there. Well, currently you can. But no, generally you can't. All right, so let's I forgot to acquire the. So we define our room again, and we ask whether it's lecturable. No, it isn't. By the way, this question mark thing, it's really just methods may end with a question mark. That's it. It doesn't mean anything. It doesn't have any constraints on the implementation or on anything. It's really just you may have question marks and exclamation marks at the end of a function name or method name. But in general, people use these question mark things for functions that only return booleans, because this is what you expect to happen. All right. So our R1 isn't lecturable, and R2 is a lecture room. Has a different name. It's on a different floor. Doesn't really matter. Missing keyword capacity. Obviously, we said we want to have a capacity on the lecture rooms. Good enough for online lectures. And R2 is lecturable, I guess. No. Oh, yeah. Yes, of course. Yes. This is exactly what this name error is about. So either we add an accessor capacity here, which produces the capacity function, which is then just called here, or we add the add here, or both. So if you do it like this, the function, the getter, which is defined by this line, is then just called here. That was a question, wasn't it? Yeah. Okay, good. All right, so again. We found a lecture room again, ask it whether it's lecturable, and it now is. So when we are defining rooms, we of course need some way of bookkeeping. So whenever there is a new room being built, we have to remember it somehow. So what we do is, I said add things are class variables. So we said, say add rooms. This is the class variable rooms. This is is an empty array unless it is already defined. But this is not necessary, because we can just say it is rooms unless already defined. So if rooms evaluates to something else than nothing, it will be the right side will never be evaluated. And if rooms evaluates to nothing, it will be assigned the empty array. And what we then do is we take rooms and add ourselves. So whenever a room is initialized, it is added to the global, that is to the class rooms array. And of course we want to access it. But this isn't quite what we want, because this is not something that has nothing to do with the instance, but it's something global, something of room. You want to say rooms, or let's say all, and this is how class methods are made. There are other ways, but this is the most straightforward way to do it. So all self.all just returns the list of all rooms, and just to make sure an empty array is returned if no room was defined before, we can optionally assign the empty array here. So again, we define R2, we define R1, and we then say room dot all, and we get an array. And we could, for example, map, another nice syntactic sugar. So this is the obvious way to ask the two rooms for their full name. Oh, by the way, you can for the blocks you can either use the do end syntax or the braces.
Curly brackets. No, those are fast.
I think it's braces, isn't it? Aren't they?
Braces.
Anyway, these curly things. So this is a short way. Generally, when you're having blocks that are very, very short, they really don't contain a lot of stuff. You're using these curly braces. Otherwise, when you have a multi-line block, you generally use do end. There is another small difference with operator precedence, but we'll go into this now. It doesn't really matter. It's really just in very, very special cases that you realize the difference. So yeah. Somebody was question? Yes, sure. Yes, this is true. There was a question about what to do when somebody evilly adds a string capacity. What we can do, for example, is at this point say the capacity we want to explicitly turn it into an integer. So this 2i is the way to cast something to an integer, and everything that can be cast to an integer will be cast to an integer. So every class or every object that implements 2i will do that and return an integer, and everything that does not. So if you're adding something that is just never integer like. Will raise an error, and that's the stuff you do then. So you don't really lose a lot. For example, the empty string 2i is 0. The even nil to 2i is 0. But we can, of course, check the type of things. We can do this on the left. That's it. Yeah, I'll go into this in a second. Just another word of syntactic sugar. What we're doing here, for every room, we're just calling the full name function. And this is quite a lot of code. So what we could do instead is this, which is really just a shortcut for map the function with a given name to all the objects in the array. This works with each and with every function you'd expect it to work. You'll find this a lot because generally or very, very often you're just adding you just need one parameter or one value of an object, of all the objects, and for example add them or whatever. Yeah. No. The point is, the question is whether or not it works if this is not a function that is defined in the class. In Ruby, we have a situation similar to Objective-C. In Objective-C, you're not talking about methods being invoked or about functions being called, but you're talking about messages being sent. And this is very much the philosophy behind Ruby in this point too. This is what duck typing is about. So if the thing behaves, if the thing knows how to handle a full name call, the method or the message full name, it will just receive it. And you can just take one room and ask it respond to full name. Whoops. Yes, obviously rooms respond to full name, but to full name they do not respond. And there was the other question about type checking. You can, on the one hand, you can always ask whether something is with, for example, capacity.class equals integer or so. You could just do that. But there is always is a. So R1 is a room, but it is not a lecture room. And lecture room is a subclass of room, but lecture room is not a superclass from room. And of course, if you ask if this is a whatever string, it is not. Yeah, I think we'll go on here and. Yeah, we need to be a little bit careful. I have so many ideas where to go, but you should stick to the more reasonable stuff. So there's another probably reasonable question, that is, I have the list of all rooms, but I really just want to have those that are actually lecture rooms. So because I want to have a lecture there. So, what to do? I say, I'll take all of them, which is just a call to this function, and I select those which are, which are lecturable. Die können. Das I could just.
Ja, ich schiebe das nochmal.
So Christoph is now pushing the picture over. All right. Thanks for the hint. Okay, so yeah, we can then make this more reasonable again. All right, so we now define all lecture rooms, which takes the array given from all and filters it and returns a new array which contains only the elements for which this function is actually true. And again, given the syntactic sugar we had before, we could just say also lecturable. Of course, we could do this outside, but we want to have an all lecture rooms function. And we could then even decide to overwrite the all function in lecture room to just return the lecture rooms. But yeah, I guess this is. But let's have a look whether it actually works. Oh, where's my require? So now room.all is the two of them. And rule all lecture rooms is just one. And hopefully the lecture room, yeah, affected is. All right. So, okay. We now have a way to add new rooms just by instantiating them. We don't have to explicitly add them somewhere because we do this management in the initialize call. And we have a way to query either all rooms or only those in which lectures can be held. So, but now, of course, somebody wants to implement an app using this great library. And so what we need is a toJSON function, which gives us the chance to pipe this into some crazy API or whatever. And the easy way to do this is we just, oh yeah. What we need to do is we need to say name is name. This is pretty inconvenient because we have to escape all these inner quotes. There are a couple of ways to define strings. One of them is to put them into percent and some bracket or parenthesis like whatever, and everything that's coming up until the matching closing one will be a string which in which interpolation is working. Another way is to use multi-line strings. Oops. Now everything is a string up to the end, up to the point where this token shows up again. So this could be EOT or XXX or whatever you like. So this is probably the most convenient way to write it because you don't have to have any strange characters there. So we have name is name, we have floor is floor, we have building is building. We're closing this, so now we should be able to convert our rooms into JSON objects. Right, so this is our neat JSON object. All the white space comes from the way we create the string. We could, for example, add a. Well, these multi-line strings, they are really strange. So if we want to strip the remaining white space, we have to add this strip over here already, not at the end. This is it doesn't really matter, but anyway. So now we have this made up, but we find that if we have quotes within name, floor, or building, then everything would break. So we need to have some escape JSON function. Oops. And what we need to do is we just substitute any occurrence of double quotes with / double quote. All right, so this should be working now. This is working, but it's definitely not a cool way to do it. And when I'm praising the dynamic nature of Ruby, we should do things like this. For example, we take, oh no, name, building, floor, or the other way around, it doesn't really matter. And we map this name. So we are using at is first name, then building, then floor, and what we produce is a string or whatever. I don't mind. Which contains first the name of the attribute at, and then again in double quotes the JSON escape version of So what do we want to do? We want to look up the attribute name and look up the attribute building and so on. So what we can just do here is we could just send ourselves this attribute name. So what madness is this? If we have a string and we say send instead of directly calling the function, we could always use send, which, well, does mainly the same thing, apart from, being dynamic in the sense that you can put in a variable in there. So, and of course we could not only use this for attributes, but also for just proper functions like full name. Oh no, not here for R. This is obviously stupid. No, where? Oh, just R2. Sorry. Yeah. So what we're doing here is we are producing. We are taking an array with names of the functions that should be converted into JSON and make a list of strings, and then we just join this list with a comma, and for convenience we give this some temporary name and we return that's it. So this feels a little bit cleverer, I guess, but attributes. So now we define constants, JSON attributes equals to name, building, and floor. And when we are calling this to JSON, we're iterating over the JSON attributes and getting for each of them the key, the name of the attribute and the value of the attribute, produce a list of these, join them with a comma, and add opening and closing curly braces. Unless I did some typos. Oops, no. So we need one of them, r2.toJSON. All right, so this worked, but we might find that this is a lecture room. And for lecture rooms, we of course need the capacity, which is what distinguishes it from from an ordinary room. So what we can do, we can go to the lecture room and just, oops, and override the constants. And it should now use the constants of the subclass. No, it doesn't. If I write it just like this, the constants lookup follows just the actual scope where it is defined. But if I say I want my own class and then the JSON attributes constant, I will explicitly so if I am a lecture room, then self class is lecture room, and I'll get the constant JSON attributes of lecture room and not the one of the superclass. All right. So in this case, everything worked, but since the capacity is an integer, it just didn't want to use gsub, which is not available for non-strings. Anyway, this is all very made up. So. All right, so now we have a capacity of 7. You'd normally say in this escape JSON thing, so when this is a string, you gsub when this is integer, isn't it? Yeah. Yes. Yeah, very good question. The question is why it is necessary to use this self over here in line 25. All right. I'll answer the other question because it's also not trivial. So this self would normally not be necessary if it was an ordinary function, but class, sadly, is a keyword too. And just to make sure, we are not talking about the keyword class, which would break everything, but we are talking about the method class. We have to explicitly specify self dot in this place, and when this self.all, when you define, this is the way a class function is defined. So instance functions are just defined by def, and class functions are defined by def self dot whatever name. Yes, this is This is mainly what static is.
3 months ago, I had the same problem to understand it. This behavior of self is a little bit confusing sometimes. So yeah,
for you.
Yeah.
The point is, it is not exactly the same thing as a static function because. Oh, well, no, I shouldn't go into this. But it is mainly the same thing. There are some differences between, yeah. No, probably not. we could meet for a beer or something like this, and I will talk hours and hours. But it's really just it tends to be confusing. Okay. Oops. So this is another nice language construct. You know switch cases. This is really just very much the switch case you know from Java. But case does not use the equals operator. So, but case uses the three equal signs operator, which can be overridden as you like. And one is obviously equal to one, even with three equal signs. Otherwise, it would be really nasty. But it's written the other way around. This is not commutative. So anything is three equal signs equal to its class. And this allows you to just write things like this. So you could have when Christoph, then Divdov, when string, then whatever. Yeah. So you could the first match is used. The first match is being used, and you can you can use it to branch by almost everything. You could also do things like regular expressions and things. Even I think with Ruby 3 there are even greater ways to deconstruct the actual objects. So you can really case switch by the structure of a hash or things like that. But this is really something I've never used it so far, so I'm not even sure about the syntax, and it's not that important. But this is really neat because you don't have to use giant if chains, but you can use case for things where you normally have rather complex if statements. So I have never tried what happens here. I think this three equal signs thing never produces some kinds of type error. It just returns false if it doesn't know how to deal with it. So we're trying to compare this. Oh no, R2, yes. Okay. I have no R1 yet. Okay. So yeah, we can. This escape JSON is now more stable, so we can now handle integers properly. And if we get some data type that we don't know how to deal with, we just tell that we don't know how to deal with it. We'll just raise an error. All right. So now. Should work now. Yeah, so now capacity is 7.2. The quotes come from from here, which is Of course, this is not a clever way to turn something into JSON. This is really just to show you the principal way of doing these things. All right. What else did we do there? These reset things doesn't matter. Can you say? Yeah, it's slightly different from what we had, what we did for the assignment.
We are looking at the screen.
Yes, sorry. So what we should probably this implementation is way better. Yeah, we should probably just add it. I'll just put it into the repo too.
Leave it as it is.
Hmm?
Leave it as it is.
Yeah,
It's fine.
I don't mind. All right. So this is the point where we stop with where I have nothing else prepared, and I thought we'd just tell you what we want you to do until next week.
Yeah.
And this is something.
I should too.
He's the boss. Yes. Yes, bitte. Yeah. Yes. Yes, of course. I can, of course, ask every object for its instant variables, and we can. I don't know. I always mix up the order of the words, but you can. I can get the instance variables even, but this is something. Yeah. For example, this. Oh, I could tell you this. No, when you're using IRB, this interactive Ruby thing, and you have an object and it is shown to you like true, then what actually happens is true.inspect is called, and this is what is then printed. So r2.inspect is what you get to see when you're calling, when you're just evaluating it, and the just to get some reasonable feedback. So if we said true, define singleton method inspect do, and we then just return this is really just a just try to make you happy. This is really just the way it is printed. This inspect is really just there for printing. But in the standard implementation of inspect actually uses this show all instant variable things to just create this string here. Yeah, this is really just the way the string is constructed.
I don't have the repository template here on my PC.
Why not? Did I push it?
You pushed it.
Oh, okay.
But not locally.
Oh, yeah. Okay, so I'll just...
So, the graduation process for this course. We have weekly assignments. The first and the second, maybe the second, will be with Ruby. And from then on, we start a Rails project and continue on with this Rails project. I prepared a blog post for you. It's not published yet. Where I repeated step what you need to do to complete it. The main steps are installing Ruby, installing the RVM, the Ruby version manager. Then you go to GitHub with this link and accept the assignment. Then you reload this page. Now you have your own GitHub repository, which is initialized with our example code. The room RB contains mainly the same. Oh, fuck. I forgot to switch to my computer. Okay, you click on the link here in my blog post, and you will, you can create your own GitHub repository for this assignment. Then you just clone this repository. First assignment. Here you can find the room RB, like Peter constructed it or wrote it. And your task is to complete the person class. What you need to do is make these tests happy. And you can try this test with.
Yeah, we in the I have in the tests directory there are two unit tests, and both contain a brief explanation how to call this.
Yeah.
And I guess you should not have any problems understanding what's going on there. The room RB contains slightly different code because as always I lost track. So if you want to see the things we did in the sorry, accidentally we did live. I just added the live RB, which is just what you saw today, and the other things, well, very much the same, but some details differ. So probably if you don't find what you were looking for, you can just have a look at the live RB, which is what we typed today.
Yeah, so I tried one time to. First, I have to execute this gem install.
Oh yeah, probably. Yeah. Sorry, but in the Ruby world, the way that libraries are distributed is gems. So Ruby gems is the thing, and if you just could you just open rubygems.org?
Mm-hmm.
So rubygems.org is very much what the npm stuff is for JavaScript, or the Maven for Java, or whatever is currently the hot shit there.
Now it's in German.
Yeah, and so if you on the command line you're installing the dependencies by gem install something. When we are going to the bigger projects, there is a proper dependency management stuff, but we intentionally don't want to use it right now because we try to keep things as that simple as possible. So we really stick to only a couple of just a couple of files.
So, Anna.
Ja, so gut gemacht.
Ja. So, hey. So the person test does not work. The room test should work.
Yeah, at least mostly.
Mostly, okay.
Oh no, completely. In the room test there are some tests that contain some implement me stuff, and we want you to add reasonable stuff there. Just of course this will never be production ready. Just do one or two edge cases just to show you get the idea of all this stuff.
Just for you to get a little bit used to Ruby code. not to do the right thing or something like this. So we won't check this week for any straight or any whatever. We just want to make sure that you're getting started producing Ruby code. So after you changed your didn't GitHub rename the master to main?
Probably not my Git. I don't know.
Huh. Whatever. Okay. As I mentioned, I wrote in our blog post that you create a clone this repository and then switch branch to assignment 1. So just git
Check
branch check out assignment 1.
Minus B. Du bist die sehe nicht am Bildschirm.
Ah, okay.
Thank you.
So. Yeah. Error, pass back.
Minus B. Check out minus B.
Yeah. Switch to branch. Then you do your stuff. Something. If you just want to use your console, you go now git add everything, and then git commit -m.
Everybody who commits a DS store file has to pay for a beer.
Yeah. Whatever. Then git push.
Yeah, fuck. Yeah, that's that.
Okay.
This is a good. There's this command line tool called fuck, which I use in this case always because it really just fixes the last error message.
Yeah. Okay. Now it's pushed to my remote repository, and now finally you have to create a pull request to the master branch in this case. Not in the template here. Compare and pull. Leave here a nice message and create a pull request. And that's it.
So we'll have a look at the pull request then.
Yeah, and we will go through the pull requests. The deadline for each weekly assignment is on Friday evening. So after the lecture next week, you can ask your questions about this assignment. If you didn't understand something or need a little bit of support, and then you have another day to do whatever you need to do. Yeah.
Yes.
Friday. Friday. At least it's Friday, not Saturday. Yeah.
Yeah.
No, next week. That's the reason. The reason is because it's private. So now you should find it. Now you should find here on our blog, on the SAE blog, on the web engineering exercise assignment 1. Yeah. Any questions about this? No, that's great. So, yeah. Does
Excuse
anybody
me?
understand what he said? Yes. We upload all our recordings of our lectures to YouTube, and you'll find them.
Seriously?
Seriously.
Fucking hell.
Yeah. You'll find here in this here in a link to YouTube, or you just go to youtube.com and search for whatever. SE Kassel? Yeah. Here you find our YouTube channel, and here will be another playlist for web engineering.
Oh, wow.
Oh, Peter is getting nervous about becoming a YouTube star.
I would have changed my hairstyle.
Yeah.
And remember to leave me a thumbs up.
Yeah. And don't forget to click the bell. Yeah.
And buy my hair conditioner.
Yeah.
Yeah, we even have the infrastructure for that.
Yeah. Yeah. Yeah.
All right.
So,
Folks,
from our side, that's it for this week.
Thank you so much.
We only took 2.5 hours, so we're just in time. Tschüss. Bye.